Hello everyone, this is Aishwarya A, currently studying in 6th semester, Department of Electronics and Communication Engineering at Sri Venkateshwara College of Engineering, Bangalore. Today, I'm gonna present on a topic, microwaves and antennas, and the subject code is 18EC63. Before getting into it, I would request each and everyone to please like the video. So now we'll move on to the module 1. Module 1 contains microwave transmission lines and the subtopics are microwave frequencies, microwave devices, microwave systems, transmission line equations and solutions, reflection coefficient and transmission coefficient, standing wave ratio, Smith chart, single stub matching. Now, let me take you through the today's agenda. It includes electromagnetic spectrum, microwave frequencies, properties and applications, microwave systems. Let us start with frequencies that are used for communication. The diagram below shows that electromagnetic spectrum. This spectrum has got a lot of frequencies from left to right, that is 300 Hz, 30 kHz, 3 MHz, 300 MHz, 30 GHz, 3 THz, 300 THz and beyond. The bands for these listings are given by very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extra high frequency, infrared, visible light and ultraviolet light. Frequency and wavelength relationship is given by the formula lambda is equals to C by F, where lambda denotes wavelength, C denotes speed of light, which is approximately is equal to 3 into 10 to the power 8 meter per seconds. F denotes frequency. As I told, the relationship between frequency and the wavelength depends upon the speed of light. Therefore, lambda is equals to 3 into 10 power 8 divided by frequency. Now let us look at the example. What is the wavelength if the frequency is 4 megahertz? According to this formula, lambda is equals to 3 into 10 power 8 divided by 4 megahertz. The frequency given here is 4 megahertz. We have to find the wavelength. As you all know, mega means 10 power 6. Therefore, lambda is equals to 75 meters. Wavelength can be calculated according to the given frequency, or frequency can be calculated according to the wavelength of an electromagnetic spectrum, or vice versa. Now let us move on to the frequency ranges from 1 GHz to 300 GHz. These come under the frequency range microwave frequency. Microwaves and super high frequencies, extremely high frequencies, these two put together comes under microwave frequency range. Now let us look at microwaves and super high frequencies, which ranges from 1 to 30 GHz, which is used in satellite communication, radar, wireless LANs and microwave ovens. Now extremely high frequencies, which ranges from 30 to 300 GHz, which is used in satellite communication, computer data and radar. Now let us move on to the spectrum standardizing and allocation agencies. And these are the agencies which standardize the spectrum usage, that is ITU, International Telecommunications Union, IEEE, Institution of Electrical and Electronic Engineers, FCC, Federal Communication Commission of USA, TRAI, Telecom Regulatory Authority of India, etc. Let us move on to the microwave frequencies. The subbands under these microwave frequencies are given under this band designation and their frequency ranges. Band designation and frequency range are denoted under these tabular column. We'll move on to these band designation and their frequency range. That is L band, which ranges between 1 to 2 GHz, S band, which ranges between 2 to 4 GHz, C band, which ranges between 4 to 8 GHz, X band, which ranges between 8 to 12 GHz. Ku band which ranges between 12 to 18 gigahertz, K band which ranges between 18 to 27 gigahertz, Ka band which ranges between 27 to 40 gigahertz, which ranges between 40 to 300 gigahertz, and the bands from L to Ka which lies below millimeter frequency range. Now we'll move on to the microwave frequencies under millimeter bands, that is 40 to 300 gigahertz. Their band designation and the frequency range are given below, that is O band which ranges between 33 to 50 gigahertz, U band which ranges between 40 to 60 gigahertz, V band which ranges between 50 to 75 gigahertz, E band which ranges between 60 to 90 gigahertz, W band which ranges between 75 to 110 gigahertz, F band which ranges between 90 to 140 gigahertz, D band which ranges between 110 to 170 gigahertz, G band which ranges between 140 to 220 gigahertz. Now you can see these frequencies varies from 40 to 300 gigahertz, which is under millimeter bands. Now we'll see what is microwaves. These microwaves are the another electromagnetic waves. Microwaves are like any other electromagnetic wave occupying the region between radio wave and infrared waves in an electromagnetic spectrum. The wavelength of these microwaves varies between 1 millimeter to 1 meter. These travel with the speed of light, that is 3 into 10 power 8 meters per second. And the wavelength of these microwaves approaches the device dimensions. So now let us move on to the properties of the microwaves. Why users only prefers microwaves? Because the first and foremost property of these microwaves, that is bandwidth. Example, if we take the audio signal, we have to send the audio signal through the landline. We can only hear their voice. We cannot see their face or something. So example, in the cell phone, we can make a video call, audio call, we can see the live match. This is due to the higher bandwidth. In the landline is fixed to the some particular place with a wire with a lower bandwidth. So the property of these microwaves, they are flexible with this any smaller bandwidth or a higher bandwidth. Therefore, we can use them in a telecommunication links. And the next foremost property is metal reflection. This metal reflection is used under radar and navigation. This radar is an acronym, as you all know, that is radio detection and ranging. These radar system came into existence during the Second World War. We started using these microwaves for these radar communication and navigation during the Second World War, because these radar helps to detect a target object. In a world war, we have to detect the target enemies, and it is also used in weather forecasting, and it is also used in navigation. Example, as we all seen the global positioning system GPS in our mobiles, it is a great navigating system which is used under the property metal reflection. Example, we cannot cook something in the microwave oven using some steel or some alloy vessels. We have to use some special metal to cook in a microwave oven. Therefore, we have to use some special metal for these radar system and navigation system. Otherwise, these radar and navigation will fails in the function. And the next foremost property, that is ionic sphere penetration. This is very important property that is used in satellite and space communication. Due to the curvature of these microwaves in an electromagnetic spectrum, they can penetrate through the ionic sphere. Due to this property, these microwaves are used in satellite and space communication. And the very last property, that is heating effect. These heating effect can be used in domestic, industrial and medical applications. Example, in the domestic application, we can use the microwave ovens for faster cooking, and in industries, we can use these microwaves in boiling water, converting the boiling water to the steam, welding, etc. And in medical applications, that is, we can use it these microwaves for treating the cancer patients or for some therapies and etc. Now we can see the difference between the basic communication system and the microwave communication system. Now it is basic communication system. The diagram below shows the components of the basic communication system, that is transmitter, channel and the receiver. M of t is a message signal which is given to the transmitter, and M cap of t is a modulated signal which is received at the receiver end. Now we'll move on to the basic components of the communication system, that is transmitter, channel and the receiver. This transmitter converts the source or any information to the signals. These converted signals are sent to the channel by the help of antenna if it is applicable, and the channel will receive the given signals from the transmitter, and the channel can be wire or wireless. In this wireless channel, atmosphere acts as a channel, and wired signals, coaxial cables, twisted wires or optic fiber is used in a wired communication. And in the receiver end, which reconvert the received signal to the original information. The information or a signal obtained from the channel to the receiver, these receivers will convert these received signals to this original information. The output is received at the receiver end, that is the original information. Now we'll see the microwave communication system. Microwave communication system also contains a transmitter part and the receiver part, but it is a wireless communication. There is no optic fiber or a wires used in this channel. Therefore, it is a wireless channel. Then we can see the transmitter part here. Microwave source, wave meter, calibrated attenuator and stands are used in a transmitter part. And in the receiver part, output to the oscilloscope or a power meter, waveguide termination, crystal mount and stands are used in a receiver part. Waveguides transmitting on antenna and receiving on antenna are used for a transmitter and also a receiver. It is a major difference between the microwave communication system and the basic communication system. We have to know that microwave communication system is a wireless communication. Here, atmosphere acts as a channel for a communication between transmitter and a receiver. Thank you. Thank you for watching.